Hey everybody, this is Larry. This is me doing a virtual contest for Weekly Contest 491. Hit the like button, subscribe button, join me on Discord, let me know what you think about this contest and this virtual contest thing. This is basically me doing this live. I have not seen these problems yet. I mean, at least not from this contest. Maybe they reuse problems, who knows. And this is just a live recording. If you're looking for explanations, I have different videos for those, so check those out and, hit all the buttons, like, support, or, whatever the kids say. All right, am I ready? Yeah, probably. Let's go. Start practice. Go, 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 go. Do. Boom, 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 boom. All right. Yes, remove all trailing routes. Okay, so, how do I want to write this? I mean, n is small, right? So we'll just write, well, A-I-O-U, right? So just like keep it dumb, right? And is that the ID? Did I click on it? Yeah, okay. Pretty straightforward. Minimum cost to split into ones. You split an x into two positives, so okay. Cost of this is a times b. You turn minimum. It's just all number of ones, right? So what does that mean? And n ones. It's one at a time, right? Isn't it one at a time? So and n is 500, so we just do the math. And am I getting confused? Oh, maybe I am. But we could just do the I mean, if it's not one at a time, I thought it would be greedy, but like, because 1 and 5, I guess there's a cost of 5 and then 1. Okay, but yeah, I mean, we could just also just do dynamic programming because I don't want to think about it. I think that's fine, right? So for x, we just go, if x is equal to 1, then we return 0 as cost. Otherwise, we split it. Whatever. We split it. Best is equal to infinity, say. Best is equal to min. Best, what are we doing? What's the split? F of I plus f of x minus I plus 8i times x minus I, right? Something like this. Is that not right? Should be right? Am I infinitely looping for some reason? Apparently I'm infinitely looping for some reason, but do we, oh, this could be 0, I think. So actually this should not go up to x plus 1. Okay, 3 and 6. All right, let's go. You'll probably actually cache this over different test cases, but I think this should be fine. 500 square. Alright, minimum bitwise OR from grid. Okay, so we have an R and C grid. One integer from each row of the grid. Return to the minimum possible bitwise OR. We have a lot of possible rows, but number of items is true. How would I do it? Hmm. 10 to the 5th. What's 10 to the 5th? 10 to the 5th is 2 to the 20. 20 bits. 20 bit times n seems a little high though. So, How would I do it? Bitwise OR. You kind of want it greedy, right? So, I mean, with these things, you just kind of want it greedy, but not in like a normal greedy way, but you want it like a bit at a time, right? So then maybe we write, what's it? So B is equal to 20. 2 to the 20 is a million. That's good enough, right? Okay. And then we just want to see if it's possible to do yeah, like for I if possible I, then something like this, or current is equal to 0. If it is possible for it to be a 0, then nothing happens. And if it's not possible, then current to do 1, right? Yeah, okay, something like this. And then we just return current. So index say, and then what we want to write is, what is this function, right? So is it possible to get a number, this is wrong, I don't know why I wrote it this way, number from every row to get 0 where the prefix is less than current, something like this. I mean, I'm probably not that precise, but I'm trying to write code and not this for now. Maybe an explanation will clear it up. But okay, so then now, because then now this would be B, which is 20 times R times C, which should be good enough. Okay. Oops. So then now, all right, found is equal to true, meaning that, okay, so if grid of row column, because basically it has to, what am I saying, right? It has to have the prefix, it has to have, so for every bit in the current, if it has a 1, this can be anything, but if this has a 0, so this does not add to the current. That's what we want to say. So how do I write that precisely? So maybe something like this. I don't know if I'm off by 1 here. That's the part that I'm like hesitating on. So something like this. If this is not equal to, or if this is equal to current to the index, right? Because what that means is, and maybe we could do C lookup. Is it index or index plus 1 or minus 1? I have to. That's gonna mess me up. Okay, so if this is the case. If this is the case, it means that this is a valid thing, and then grid of is greater than 0, something like this. If this is actually equal to 0, whoops, then found is equal to true. I don't know why I had it this way. Oops. So if found, then we are good. If not found, then we just return false. It's not possible, and return true. This may be index plus 1. Okay, let's think, right? So let's say index is 0. We check the last bit, then this shifts 0, which I guess it actually doesn't matter because current would not have anything on that bit, but it's still not precise. I think this is actually index plus 1. I think it actually like would work out in either case because we don't set it yet, but it is definitely not precise. Okay. Invalid syntax. Oh, I don't know. It's just a long word. So, if the okay, maybe this is a little better. Okay. 357. I'm going to YOLO submit. I think this is right, but it could be off by 1 and something silly. I think okay, good. Count subarrays with k distinct integers. We have nums k and m. Return number of subarray. What is n? N is 10 to the 5th. Just want to make sure. Number of subarrays such that subarray contains k distinct integers. And each distinct, oh, wow, what? How would I think about this? This seems like one of those problems with like a data structure crazy problems. So I don't know how to make of it, but constraint. Okay, nothing that we can really exploit on the constraints. Maybe this part, and maybe there's some pigeonhole, but can we do some like oh wait, at least, not exactly. Okay, that's actually, and we're given M. Okay, I think I read this confusingly a little bit. It is kind of confusing. Okay, so given M, number of subarray where, oh, exactly K, huh? So there is a sliding window component, right? Because when you get a new number, because they have exactly K distinct numbers. I think, is it not just sliding window? I feel like it should be just sliding window, right? Just because, yeah, maybe. We'll see. I mean, I might have to set this up a little bit, but right. And then here, there is some stuff that we have to think about. I mean, I think, yeah. Let's just write it in a dumb way, and then we'll clean it up with more data structure. I think it's possible. But okay, so here we go do. Right. Yeah. And then now, while length of f is greater than k, f of nums. So this is like just the basic structure, right? But I think we have to actually do a little bit cleaning. But right, but if length of f is 0 or equals to k, then we do some stuff, right? And then we just return total or count, right? And count should be at most n squared, so that's fine. Okay, so that's the structure. I don't think that's wrong. We just have to add some more data structure to keep track. Okay, so here maybe I have a sorted list, right, of f of frequency. So then here maybe I write f, so previous is equal to right? So then now if previous is greater than 0, ff, then we remove previous, otherwise we add this, right, as the frequency. Okay. Okay, so then now while this is true, we remove. Okay, so previous is equal to, if this is 0, then we do this. Otherwise, if it's not 0, we actually have to add it back in, right? And then now here, if f k could be has to be greater than 0, right? So this always exists. If this is at least m, then we do something, which is, oh, we have to count the number of arrays, right? So it's, maybe we could, can we do a binary search? So it's not the longest. If it's longest, then we're done, but count makes it a little bit trickier. How do I get the, so okay, so this is the longest. How do I get the shortest that I can get to count? This is the longest. How do I get the shortest? And you can use log n, but I mean, how do I write that? I mean, we basically do another while loop until this is false, but then we have to kind of keep track of it so then we can, yeah, so then when we add a new number, that also keeps track of all these things, right? So okay, so while this is true, how do I keep track? I mean, I guess we just store it somewhere, but I'm trying to think about trying to be careful a little bit. Yeah, I mean, I think we just have to track it, really. Okay, I think like here, right? So then, okay, so new number is equal to false, and then if we're ever in here, then that means that this is true, right? So then if new, okay, so here if new number, then we keep track of previous left is equal to this, right? Okay. Okay. Left boundary maybe? I don't know. Alright, let's wait. Okay. And then now we do a while. Right? Then now we also move left. So maybe we could copy some code here, but yeah. Yeah, I think it's just copy and paste for now. Yeah, I don't want to. Maybe we could abstract it. I don't know, but yeah. Okay, so then now this is the first case. So then it's going to be something like left minus previous left. It's going to be the answer. Because the left is the new boundary, right? Is it +1? No, because this left should be past it, right? Oh, if it's none. That's the thing that I thought there's an invariant that this is always going to be none, but oh, the first instance is going to be the new number is true. How do I get the first instance? Yes, first instance is just 0 then. Yeah, if we never had more than whatever. Okay, that's not great. Oh, this is wild. This, but no. That doesn't make sense though. We moved. Okay, so wow. But this should that command under, right? So that means something is really wrong for now. So if this is true, right? Let's just print this real quick. We start this. So it's going to, okay, so we move this. Oh, I see. So I guess we have to, while length of f is equal to k, because, or this, right? Something like that, because then it should be 0 really, but is it n? Yes, it's an n actually. All right, 1 and 6, which is very wrong. Let's see. So we have right, left, previous left, right? So on index 3, left is 1, this is 0, that's good. But then what the next one? The next one, is this not true? It goes up to here. Oh, no, wait. Yeah, because when you add this, it doesn't go back to the thing. Huh. But it doesn't count the oh, actually, no. This actually should just go on all of them, not just this. Assuming if length of f is equal to k, meaning that we have enough numbers. No, even that's not true. I mean, because we can remove numbers in a way such that it is less than 1 or less than whatever, but just have to make sure that it gets triggered once, right? So if this ever good is equal to true, good is equal to false, then this will always have some stuff. So then here, as long as triggered more than once, I think this is fine. But I think now we have to part 2 or example 2 is wrong then, right? I don't know why we moved it. So 1 1 is going to be 1, 2 is going to be 2. That's not right? 2, we don't update the previous left. Why? But this was true, right? Oh, this is messed up because then now length of f after adding the numbers, so the two invariants don't mix. Wow. Huh. My invariants are already messed up, as you can see. Okay. I don't think I could just hack it like this. I have to, let me step back and think. Okay, so how would I even write this then? I mean, I guess we just have to keep track of two things. We keep track of the min boundary and the max boundary, the longest boundary and the shortest boundary at the same time, I guess. Okay, fine. Maybe that works. I don't know if that works, to be honest. But yeah, okay, fine. I'll give it a try though. Okay, let's just do. Okay, let's quote this first. Just to make sure that this is at least still right. Okay, so then now, if this is true, then we just track it, right? Okay, so right. Answer that append left, else so just so then it's not possible. Then we just append -1 for now, I guess. I don't know. Maybe just say n for now, right? Let me print it out real quick. Unexpected indent, that's probably true. Only really, I mean, I still want to keep that code, just not there. Why is it so annoying? Oh, I guess actually this is fine. Okay, so 5 5 5 0, is that right? Oh, a 5 is infinity. So then here, okay, so that's right. And what we want to do that. This is just n. Maybe I should, instead of n, I do infinity, so it's very clear. But okay, fine. 0 1 2. Okay, so that's right. And then now we can just long left, right? And now we do this. So then here, that's for long left. L left is equal to long left, something like that, right? And then here we have maybe max left and min left. Maybe that's what I should have called it. Oh well, it's too late. Yeah, it's fine. And it's going to be mostly the same. structurally, except for now. This part is, yeah, instead we go, yeah, this part, maybe, hopefully. Not super certain about it at this point, honestly. Okay, so then we have this, right? This is the min left. So while this is true, so then now, now I think we just do left, maybe, right? Let's print it out real quick. What? Oh. Weird. Is that true? That doesn't make sense. This cannot be that left is equal to 0. We remove. So then if we remove everything, this has to be 4. So what's going on? Huh? Index, list index, why? Delete it. Huh. Huh? If this is true, then this has to have something. Right? No, left could be exactly, no, I guess. No, because then this thing would just be forced if left is greater than, if left is equal to right plus 1. What? Why? That's weird. Okay, so this is on. Oh, I'm just dumb because I don't know why I had it out here. It should be inside. I thought I had it inside, but then I just noticed that. Yeah. Okay. So then now it goes 0, 1, 0, 1, 1, 2, 3. Yeah. Okay. So then now, yeah, count is equal to 0. I know that we initialize it, but whatever. Min max in zip of min left, max left. Count we added by yeah, I think that's fine. Yeah. Did I mess that up? Min, max. This is max. This is min. So this should be just 2, right? 1 minus. Huh? How do I? Am I bad at math that badly? What? How did it get to 15? And 4. Huh? I mean, 15 is like maybe. Oh, did I just do it the other way? It's my max. Max left is the leftmost. So this is the max and this is the min. I see. I guess max and min is a little bit confusing for me, the way that I wrote it. But I'm just gonna write min. Okay, looks okay. It's linear, so well now it's n log n, but we'll see. I don't expect this to be right, but I feel like because these kind of greedies is very tricky. I feel like, but yeah, okay. So I mean, this is clearly wrong. So k is equal to 1. What is one unique number? So so this is 1 and this is 1. I think k equals to 1 I mean, I'm not surprised that it is wrong per se. Oh, this is kind of weird though. But why is this wrong? Oh no, because it's 1 and 2. 2, okay. What does 2 mean? Here. 2 means that it goes, what? I'm confusing the max and the min notation, but okay. So here, maybe I just, I mean, I think one thing that I'm trying to figure out is whether k equals to 1 is a special case, which we can figure, and we can special case it, right? This is easy to solve. But then now I'm like, well, like, if I submit this and I say I have to write code here, would that be enough? Or am I missing like a more general idea? So that's why I'm hesitating, because we can definitely do this. And it is possible that k equals to 1 is a special case because of the way that I handle like stuff like this is a little bit awkward for sure. So maybe I'll give it a try, right? Yeah, then proceed in nums, right? So streak is equal to 0, count is equal to 0. So yeah, previous is equal to none, right? So if c is equal to previous, then streak increment by 1. And then just count is equal greater than streak minus m plus 1, but not negative, right? Else, and I think this is actually whatever anyway. Else streak is equal to 1, previous is equal to c, and yeah, and that's it, I think, actually. Right? Yeah, maybe. Yeah, so it fixes it. I think this is a special case that I didn't really, maybe I should have considered, but what did I change? Why is this? I mean, I know that did I like undo too much or something? Yeah, I don't know how that happened. I think maybe I just clicked on undo or something, and then it, because it clearly, as soon as I submitted, I noticed it, but then I don't know. Okay, still wrong answer though, so it's not just that. I don't know. That's a mess. Oh, they have a big number, but that shouldn't be a matter. Okay, m is equal to 2, k is equal to 3. What's k again? K is the number of distinct numbers, and where m is equal to 2. So yeah, basically this. But I think I undo to get the print statement, but then I undid extra stuff by accident. Anyway, min left. Maybe this is not the right way. Like, I'm not super confident about this idea. But yeah. What is my invariant? So this is gonna be 0. As in, this 0 is a little weird. This one is actually correct. So so the max left is correct, but the min left is wrong, I think. Okay. So what's the min left? And that's what I was talking about with this case. I was like, I don't know that I'm confident that that's enough. But and I made an extra typo anyway. But okay, so here this is wrong. We had this. So this is true. Right? At the last element, this is true. Right? So why would... Oh, I'm dumb, right? Because now length of f is greater than thing, right? So okay, I guess how did I miss this? So we still need this, but we just don't. Also, we don't need a new number thing. So we definitely still need this because it just makes this not possible, right? So, yeah, maybe this should have been an or, but okay. This still looks right for the other ones. This time I'm a little bit slower because I YOLO submitted, even though I noticed these two are wrong. Okay. I mean, that's an obvious fix. I don't know if it's enough, but it's an obvious fix. Like, I don't know why I removed it. I think I just kind of got caught up on the asymmetry of things that I kind of got confused. But we definitely need to, right? Because length of f can be greater than k. I don't know why that was like test case 900, because this should have been wrong for a lot of things. But yeah, I mean, one of the wrong answers was just me not reading the example. K is equal to 1. I'm curious whether this actually fixed the k is equal to 1. I just, like, maybe that was just me being dumb. And maybe it was, yeah, huh. Yeah, so I didn't need the k is equal to 1. I just but that's a tricky thing, right? Was that I could see that k is equal to 1 could be a special case, and that's why. But I wasn't confident enough, and it turns out that I just forgot about this because you need this to make sure that this was even possible, right? So yeah, so that's kind of that's a silly mistake on my part. And you could obviously abstract parts of this. I mean, this is reused here anyway, but that's, you know, not a big deal. But yeah, I think one wrong answer would have been reasonable. The second wrong answer and the third wrong answer was just silly mistakes. And maybe I rushed a little bit too much, but yeah, well. I mean, I would say my excuse, if you want one, is that it's 4:30 a.m., so I'm just a bit tired. I had a pretty fast first 3 queues too. I mean, there's a lot of cheaters still, even with the removal, but I don't know. Let's do a quick post-mortem, a retrospective. Q1 was easy. Q2 was, you know, n is equal to 500 was pretty straightforward, I think. This one is a little bit annoying to understand, so I'll explain it. But I thought it was, like, I thought it was okay. Like, I didn't think it was, you know, too bad. This one, I had the ideas, but I just didn't put it together in a way that doesn't have 3 wrong answers. I think 1 wrong end. I mean, even this one, even when I missed it, is a silly mistake, right? So I really should have gotten this on the first go, to be honest. And it cost me about 5 minutes plus 3 wrong answers, so like 20 minutes, right? We're gonna finish at 28, which would have been a maybe respectable finish. I don't know. Maybe not. Apparently, a lot of people are really fast about it, or just a lot of people cheated. Who knows anymore? Yeah, that's it. That's all I have for this one. Let me know what you think. Thanks for watching. And yeah, obviously, if you want the explanation in more detail, we'll go over it in this own video. But yeah. Stay good, stay healthy to your mental health. I'll see y'all later and take care. Bye bye.